All right, so this is day 1 of chapter 5, but we're starting today with a quick going back and looking at review of chapter 4, a little bit with solving systems of equations. And this is where you started, so if you're watching this on video and you weren't in class, you're going to want to pause this and you're going to want to determine, using this information in the nutritional information for regular and double stuff. Yes, it is spelled STUF, they're copyrighted. You want to find out, is there a way I can use this information to determine if the double stuff is actually twice the stuff? So if you were not in class, pause and spend about a half an hour working through this. Yes, it's not easy to just look at it and automatically go with, but hopefully you'll get a chance to do that. And when you're ready, come back. And then this is one of the ways that we could go about doing it. So there's the picture of the two cookies. I mean, obviously you could just measure the height and say, is it twice the height for height? Which, I mean, for anybody that cooks out there, you know, all you really have to do is take that stuff, whip it up, put some air in it, and boom, it's all of a sudden now taller. So it would technically be twice the height, but is it actually double the stuff? When companies make claims, they have to validate it somehow. So one of the ways we could look at is doing calories. Others looked at it and tried to do with grams. But if I let W be the calories in a wafer and S be the calories in a single stuff, I have one cookie that's 2 wafers and 2 stuffs, and that's 70 calories. And that was because there were, 2 cookies, right? 2 cookies in a double stuff serving. And then 3 cookies in a single stuff serving, so that'd be 2 wafers and a stuff. And then you could take this and solve for W and S and find out that the stuffing calories, I think we said for a single stuffing was 16.77 repeating. And then you could find the calories for wafers as well. Plug it back into the other equation, and you'd see that here it's 16.7, here it's then 33.4, which was twice the stuff. The question would be, would it be the same? Would we still come to the same conclusion if we were talking about grams? I'm not going to cover that in class right now, but and you might not typically think, oh, I'm going to do this when I'm looking at things. I'm going to automatically set up 2 equations and 2 variables. But it does work for this. If you ever take me for stats, we'll probably do a similar thing, but instead of that, we'll look at the mass, but we'll actually weigh them out to see if the weights actually are consistent that way, because you're going to have some variability in products. So, but that requires a little bit more time to sit and scrape off just the stuff, weigh it out per individual cookie, and then get yourself to a place and saying, is this actually going to be twice that? But for today, what you're going to do now with your groups is take a moment, work through those problems, discuss amongst yourself if you have to, and you should, because there might be something there you need to get clarification on. But work on those couple of problems, and when we're ready, we'll move on to the next slide. We'll go through answers, then we'll go to the next slide. So when we have 7 to the first over 7 to the first, it's 1 minus 1. That's how we get this question mark. That's 0. But we know 7 over 7. Anything divided by itself is 1. Here, everything divided by itself, we know that this is 1, this is 1, this is 1. Anything divided by itself is always 1. But then it's looking at the exponents and remembering, oh, that's right, when I have same bases, base is 7, dividing, which I'm doing right here with the dividing sign, exponents, 3 minus 3, this question mark, there is 3 minus 3, which is 0. Or in other words, 7 to the 0 power is 1. Z to the 0 power is 1. R to the 0 power is 1. 4 to the 0 power is 1. X to the 0? 3x, the whole thing to the 0 power, is 1. And now I'm going to pause there because the next one is not 1. So if you've not figured that one out, talk amongst yourselves. Who can explain why it's 3? Since the exponent is only on the x, this is 1. So what I have is 3 times 1, because this is 1. And that equals 3. What's the next one? 1. And then the last one, and here's the question, and I'm not going to answer it right now, but can I divide by 0? Everybody should be shaking their head right now and saying, no, you cannot divide by 0. Why can I not divide by 0, you say? How many zeros can go into anything?
Nothing.
Nothing and all of them.
Good question.
Does 0 have a value? No. So if I have a bucket and I want to put the zeros in a bucket, how many zeros can I put in the bucket?
0.
Actually, I can put them all in there. I can put an infinite number of zeros in there. Because if I do something like this, if you do this on a calculator, if I do 6 divided by 0, and you do that on your calculator, it depends on the type of calculator you're going to have, it's going to either tell you error, maybe it'll say syntax error, maybe it'll say undefined. It might say a lot of different things, but it will never say 0. And the reason why, when we think about this, how many zeros go into 6? All of the zeros that exist in the world and beyond, all of them can go into 6. And when I'm done putting all of the zeros into 6, my leftover is 6. Because 0 has no value. Which is why we say it's undefined. If you have 0 divided by 6, here we say, okay, well, how many 6s can go into 0? None. And another way to do this would also be to, let's slide this up for a second. If I have x times y equals 0, what must one of them be? One of them must be 0. So if I divide both sides by x, y would be 0. 0 divided by x, x's don't go in there, there. If I do it the other way around and I say x times 0 equals y, and then I divide both sides by 0, I have x equals y over 0. What number times 0 gives me another value other than 0? So if y is 5, x times what number? Well, sorry, 0 times what number is 5? That's impossible. So if I want to take away variables, I could do it like this. 3 times x equals 5. That's not what I wanted to do. 3 times 0. If I go 3 times 0 equals 5, divide by 0, divide by 0. 3 equals 5 over 0. You start doing this, and you might be thinking about, like, but we can't do that, which is correct. And the reason why we can't do it is here. Any number times 0 has to be 0. But then, let's go back up here. That's not what I want. Come on, whole thing. There we go. Back to this. I'm not going to answer it right now, but thinking through what we did up here, theoretically, what should 0 to the 0 power be? But then also over here, 0 divided by anything is 0, like we had here. Anything divided by 0 is undefined. What if I'm doing both? And then I have 0 to the 0 power, and what is that actual value supposed to be? And this gets into some of the theory behind some parts of mathematics, where some could argue that this is 0. Some could argue that this is undefined. Some could argue that this is infinity. And then we also said anything to the 0 power is 1. And so it has to become one of those three things, or could it be all three of them at the same time? I'm not going to answer that now, but we'll be coming back to that. So here's the next thing. Do this quick with your partners. Go. So right here I have 3 times 3 times 3 times 3, which is 3 to the 4th power. Because again, powers just mean repeated multiplications. 3 times itself 4 times is 3 to the 4th power. 3 cubed times 3 is 3 to the 4th power. And if you have to remember this, well, that's a 1. What are we doing with the exponents? Adding. 1, 1, 1, 1. When you multiply same bases, we add exponents. which means this will be 3 to the 9th power. What do you think is the most common error people make on that one? Most common error people will make is they multiply, and they somehow get 3 to the 20th. Well, I can understand what they're thinking. They're thinking, well, because I'm multiplying, don't I multiply? But again, remember, 3 to the 4th means 3 times 3 times 3 times 3. Times 3 to the 5th would be 5 more 3s for a grand total of 9 3s. All right? Next one, 3 squared times 3 squared times 3 squared times 3 squared is 3 to the 8th. 3 squared to the 4th power is 3 to the 8th as well. Notice here, this is 4 of them. So this, 3 squared to the 4th, is another way to write this. Here I'm adding 2 plus 2 plus 2 plus 2, 8. Here I'm multiplying 4 times 2. So when I have powers raised to higher powers, and all I'm doing is multiplying, the exponents multiply. All right, moving on. A little bit more happening here. So we'll look at that first one, and then you can work on the next ones. Here, just that's squared over cubed. So I am reducing the numerator 1, the denominator is 5 to the 1st. Or another way of seeing it is, well, let's go like this. What is my, think for a moment, but don't say it out loud. So when I have it like this, hopefully you're seeing there's more 5s in the denominator. And if you have to, you can rewrite that as 5 times 5 over 5 times 5 times 5. Then going back to practices you've done in the past, 5 divided by 5 is 1, 5 divided by 5 is 1. I'm left with 1 over 5, which is here. But then to rewrite it as a base 5 like this, what is that exponent going to become in my question mark there? This right here is negative 1. All right. And if you go with the idea that we did a couple slides ago, 2 minus 3 is negative 1. So when we're doing same bases and dividing, when we subtract, it's subtracting exponents, it's numerator minus denominator. So 2 minus 3 means I'll have, and this is kind of messy here, but this will be 5 to the negative 1. 5 to the negative 1 is the same as 1 over 5. All right, so with that, go ahead and work through the rest of these with your partners. Go. Let's take a look at this one for a second, then we'll come back to the others. 1 over 3 to the 4th. This 1 right here, I'm going to rewrite it as 3 to a power. 3 to what power is 1? 3 to the 0 power is 1. 3 to the 4th power. All right, so now I have this 1 I just rewrote as 3 to the 0. This 3 to the 4th is right there, 3 to the 4th. And when I have same bases and I divide, I'm going to be subtracting. Three to the negative 4th. So as we're thinking about exponents, exponents are multiple ways of multiplying. Exponents cannot change the sign of the base. The most common mistake that we're going to see is that sometimes people will say, well, this negative here somehow makes it a negative in front, and it does not. If this was a positive 4, my answer will remain positive. All right. Z, I don't even know what that is, but the negative exponent, a negative on an exponent tells me that I need to move it, essentially, to the other side of the fraction bar. Where is my fraction bar here with just 4 to the negative 2? I'm going to write it over here larger so we can all see it. 4 to the negative 2. If I have 4 to the negative 2, the fraction bar, as it's written right now, when there isn't one, it's all over 1. When I have something in the numerator with a negative exponent, it must transfer to the other side of the fraction bar. It's in the top, now it must go to the bottom. And when I do, this is an equal sign, that 4 is now a positive 2, or the 2 is now a positive 2. And then this will be 1 on the top. Those are identical in value. And this would be like if you grab your calculator, you plug in 4, and then you go to the power of negative 2. It'll give you a decimal. Convert it into a fraction, and we'd find that this is 1/16. Okay? But for our sake over here, all I want to see is it's going to be 1 over 4 squared. So with that, z to the negative third will be 1 over z to the third. My bottom one down here, 1 over x to the fourth will be x to the negative fourth. It was in the denominator. Now we just moved it to the numerator, so that positive 4 now becomes a negative 4. And then this one here. This is, you might already be seeing this and like, oh, here's the pattern, this is what we're doing. Bam, here's the answer. I'm going to kind of walk us through how we get there. But 1, like we did on that other slide, what is 1 equal to? Anything to a power of 0 is 1. So really what I have in the numerator is I have x to the 0 power. In the denominator, I have x to the negative 4th power. When I have same bases and I'm dividing, I will subtract 0 minus negative 4. 0 minus a negative is plus a positive. 0 plus 4 is 4. So my answer here will be x to the 4th. Or you're just thinking, wait, it's negative here, so if I move it to the top, it becomes positive. Just like here it was a negative in the top, we move it to the bottom, it's positive. So anytime I have exponents and I switch sides of the fraction bar, move it from the denominator to the numerator or numerator to the denominator, the power, if it's negative in the denominator, becomes positive in the numerator. If it was negative in the numerator, like over here, it becomes positive in the denominator. So when they switch sides, the signs of the powers changes. So next up, a little bit more going on here, some similar, some different. Might take a little bit more time, but talk with those that you're partnered with, work through these problems. It might be to a place where now it might be a good idea to write some things down as you're working through so you can explain your steps to those in your group when they say, how did you get that? All right, turn, talk, and make this happen. Go math. So with this one that I just did, I just showed the longhand way of solving this, because cubed means times itself 3 times. So it'd be 3x squared times 3x squared times 3x squared. We could have also said, well, this is 3 to the 1, which it is. And when I have multiplying only, again, multiplying only, raised to powers, then it's powers times powers. 3 times 1 is 3 to the 3rd. 3 times 2, x to the 6th. The 3x stays in the denominator. Biggest mistake I see people make is they see this 3 and that 3 and they reduce first. You can't. Just like you already talked about in one of those online discussions that we did that was due, I don't know, a couple days ago. The importance of PEMDAS or PEMDAS. All right, you have to do exponents and parentheses before you can do dividing. Then we get to here. 3 cubed over 3 is 3 squared. X to the 6th over x to the 1st, 6 minus 1. There's a 1 on that 3, so it's 3 minus 1, that's 2. 6 minus 1, that's 5. And you can leave it like this. You don't need to put 3 squared in there. And I heard many people doing it on this next one here. So this will be 3 to the 8th, x to the 16th, 9 squared, x to the 10th. And now, because you've been doing, math for it feels like all of your entire life, 9 can actually be rewritten by itself as 3 squared. So what I actually have in the denominator is 3 squared squared which is 3 to the 4th. So I'll have 3 to the 8th, x to the 16th, over 3 to the 4th, x to the 10th. And then I can simplify faster. That will be 3 to the 4th in the numerator, x to the 4th in the denominator, or 6 minus 10. Oh, 16, that's a 16. Never mind. 16 means 16 minus 10, so it's a positive 6, so it's x to the 6th. And then lastly, we have in the numerator, so what I'm going to do first is take a look at all the things that have negative exponents. I have no parentheses, so I don't have to worry about the parentheses. I have negative exponents. Negative means move it to the other side, essentially. I'll have 3x squared in the top, and then a y to the 9th in the top, because this negative 9 is on the y, so it's got to move to the other side. This y has a negative 2, which means it's going to the denominator, y squared, and I have a z cubed in the denominator. Why do I do it that way first? Because negatives oftentimes cause people trouble, so let's go ahead and make the move to make them positive. Is there another way you could do this? Yes, I'll show that in just a moment. So then I'm left with in the numerator 3x squared. I see the y's. 9 on top, 2 on the bottom. These two will reduce, so I go 9 minus 2. It's y to the 7th. That's a z 7th. And then in the denominator, I still have z cubed. And I would leave it simplified just as that. Could have I started with this and said negative 2 minus negative 9? Yes. Same bases. Negative 2 minus negative 9 minus a negative plus a positive, so that's 7. Positive 7, and then which is what I ended up with there as well. All right. I'm going to work through these quickly. We got a few more slides to get through here. But as we're doing this is just a quick reminder. 2 times 2 times 2 times 2 is 2 to the 4th. So this is 2 to the 4th over 3 to the 4th, which is the same as, oh, I know what's missing. This is supposed to be like this. Same as 2/3 to the 4th. All right. There I have z cubed to the 1, 2, 3, 4, 5, to the 5th. And what's missing, I see when I copy this over, there should be a parenthesis right there. There should be a parenthesis right there. So I'm doing the next one down. When I have it raised to powers, I'm going to go ahead and 2 to the 3rd, z to the 9th over x. And as far as simplifying goes, that would be good enough. You could just leave it as 2 to the 3rd, z to the 9th over x. You'll also see here, this is also why I always cross my z's, because you're going to look at that and say, what is that? That's a 2. What is that? That's a z. How can you tell the difference? I cross my z's, don't cross my 2's. Here what goes on is now I have this entire thing, and the top is to the -3. So I can either take that, move it to the denominator first, or I can take powers raised to powers. If I do that, I'll have 2 to the -3rd, because there was a 1 power. I'll have z to the -9th. This is all over x. And then I use the idea, the principle, that negative exponents means they need to go to the denominator. So that's going to be 2 cubed. There's the x, z to the 9th. When they transition from top to bottom, negatives become positives, and vice versa. If it was on the bottom as a negative, it goes to the numerator as a positive. So here what we're going to do is first, so the delineation here isn't super clear. There's 3, there we go. There's 3 steps. If this was the original problem, and we're missing, I don't know why all my parentheses did not copy over. There we go. And then this, there we go. So from this step to this step, there are mistakes. I want you to take a look at this and decide what mistakes were made going from here to here. Because I'm telling you, those are not right simplifications. Can you see something there? Yeah.
He didn't, on the second one, it's supposed to be 3 to the power of 3, right there.
Right. There should be a power of 3 on the 3. Because the 3 was inside the parenthesis, which means this 3 has to go onto that 3 as well. The power there was 1. Okay. What else? Yes, sir?
There shouldn't be a 3 on the y.
There shouldn't be a 3 on that y. Okay. Here's what I think. Let's go like this. I'm pretty sure my original problem was like that. The whole thing's in parentheses. And this whole thing is in parentheses. There we go. Yep. That was just me trying to remember what my original question was, because my parentheses all disappeared. So, so down here you were saying, before I had the full parentheses, you're right. There shouldn't have been that. My original problem should have had full parentheses, and the full parentheses means this 3 is also coming into the power on that y, so y cubed. All right. What else? Here z is -3. Is that right? If it's a negative in the denominator, what does the negative exponent mean? Negative exponent means it has to go to the numerator, so this is right. However, it goes to the top, and the whole thing was still a -2 power, so it's still to the -2. This whole thing went to the denominator, and that's not right. What has a negative exponent? Only the y, so the y goes to the denominator. The 9 should have remained in the numerator. But now let's just say that this was a problem you were doing and you showed that step next. here, what mistakes were made going from this step to this step? Let's see, the 6 has a negative, so it went to the denominator. The y stayed down there, and the 3 stayed on the top. So this is all good. This is z to the negative 6th, because it was z cubed to the negative 2nd. So that's right. And then this down here is 9y to the 4th, became 9y to the negative 8th. This negative 2 in this case is only on the numerator. It's not on the denominator. So that negative 2 should not be multiplied by this. All right. And then lastly, if I actually had to finish simplifying this with it as it is, regardless of the mistakes, this 3 will reduce with that 9, so that 9 becomes a 3. I'll have z to the 6th, negative 6th over z to the 6th, so that will be z to the negative 6 minus 6, which is z to the negative 12th. So my final answer will have a z to the 12th in the denominator. I'll have a 3 in the denominator from this. I have a y to the 3rd and y to the negative 8th both in the denominator. If they're both in the denominator, I'm adding them. 3 plus negative 8 is negative 5. So I'll have y to the negative 5, that's a y, in the denominator, which means I'll have y to the 5th in the numerator. There's a lot of mistakes with how my stuff transferred over here, and I don't have time to figure that out. Should have been back here on these. There's parentheses that are missing, and I don't remember where exactly they are. I believe this one is here, like this. So in a case like this, when you have powers raised to powers, it's going to be b to the 20x minus 8. Because what happened was 4 power times this power. 4 times 5x and 4 times negative 2. I don't recall how these two were set up, so I'm just going to leave those as is. And so I'm going to go to the next slide. So what? Move on to properties of polynomials. So polynomials, poly, multiple, nomials, numbers. Defining some terms if you don't remember what this means. So terms, when we're talking about polynomials, are things that are added or subtracted. So in this case up here, I have 1, 2, 3, 4 terms. Factors are things that are multiplied. All right. When we say factors, that's so as I use terminology, if you haven't heard these words in a while, just remembering what that means. Coefficients are the numbers in front of variables. Here's a variable. My coefficient is 9, or 3 squared. Here's a term. There's a variable. My coefficient is negative 2. Here's a term. There's the variable. Coefficient is 6. Here's a term. Is there a variable? No. So this we call our constant. Right? Because there's no variable. Things that don't vary are constants. So if I have something without any variables, that's considered my constant term. It's a term, because it's added or subtracted, it's a constant term. Could you call this a coefficient? You could. You could say it's the coefficient of the constant. It's somewhat redundant, but that would be okay. The degree of a term is the sum of the powers of the variables. So up here, this power, or the degree of this term is 3 because that's the power of that variable. This term, the power of the variable is 2, so this term has a power of 2, or a degree of 2. This one, the one variable, its power is 1, so the degree of that term is 1. And this one has no variable, so the degree of that term is 0. And then blank nomials, if there's one term, it's a monomial. If there's 2 terms, it's a binomial. If there's 3 terms, it's a trinomial. And anything over 3, we tend to just call polynomials. So polynomials is going to be 4 plus trinomial if there's 3 terms, binomial if there's 2 terms, a monomial if there's just 1 term. I'm going to go back to this for just 1 second. If I have, we'll use this color, 9x cubed y squared z, that's 1 term, that's a monomial. If you were asked to tell me the degree of that monomial, so again, degree of a term, this is a monomial, is the sum of the powers. The degree of this one, I'd look at the variables only, x, y, and z, and I would add the exponents. 3 plus 2 plus 1. So this is a 6th degree monomial. All right. Simplifying. Again, this, I would think that this would be somewhat familiar to you all. Group them with like terms, or in my case, I'm going to look and say, here's an x cubed y. Do I have any other x cubed y? I do not. So it stays as 7x cubed y. Do I have any other xy cubeds? Yes, I've got 2 of them, a -1 and a -3. So together they're -4 xy cubed. Grouping, I have a constant, I have another constant. That will be +7, 11 minus 4. I have a odd one here. This one will be 6x to the y. And then my last term, x squared y to the y. That exponent didn't come in real well. All right. So just grouping them up, adding the ones that you can. Adding is nothing more than counting. We're going to finish with this one, but this, we still have 1 minute. I'm going to crank through quickly. When we have function notation, so P of R is this, Q of R is that. So to add them, it's pretty straightforward, just adding like terms. 3r squared and r squared is 4r squared. -6 and -5 is -11. 9 and -9 is 0. When we get to subtracting, it's remembering, in this case, if I'm going to subtract, I'm going to start with the P of R, which is 3r squared minus 6r plus 9. And I'm subtracting all of r. So it's going to be minus. So it's going to be minus r squared. And then it's a minus, so a plus 5r. And then minus a minus, so a plus 9. Paying close attention to where those negatives are. If I'm going to subtract the whole function, I subtract the r squared. I subtract the -5, which is adding. I subtract the -9, which is also adding. So paying close attention when you're simplifying those. I'm going to go here. Quick reminder. So a constant function, when the degree is 0, which means there's no variable, it's going to be a horizontal line. When the degree is 1, we've done this, graphing linear equations, it'll either go up or go down. It's a straight line. When the degree is 2, it'll either be going both up or possibly both down. All right. And there's 1 change of direction. When the degree is 3, there's 2 changes of direction. When the degree is 4, there's 3 changes in direction. 5, you guessed it, 4 changes in direction. But you're also looking odd functions, 1, 3, and 5. If one end is going down, the other end is going up. If one end is going up, the other end is going down. If one end is going down, the other one's going up. Odd functions. Even functions, both going up or both going down. Here, both going up, or we could have it both going down. So when you're looking at graphs, being able to identify, hey, that looks like it'll be a 3rd degree polynomial. How do I know? because there's 2 changes of direction. This is the stuff that we have covered so far in this class. If you have not been submitting, so for the thinking tasks, that's what we do today in class, where I'm watching you and your groups and seeing how you're working. Are you participating, et cetera, even though you might be struggling, are you going towards that? Things like, the chapter 1 and 2, that's something that you did online that was due on February 2nd. There was a pre-reading for chapter 4. I've not actually talked about that yet. I said I'll do that in class. There were some things from lecture responses from here and here that you submitted online when we were gone that week, that Tuesday and Thursday. So if you have not been doing these, you should be really paying attention. This is all on the syllabus page. And it lists all these things along with their due dates, and you'll see that our first exam is coming up on February 15th, which is next week, Thursday. This week, Thursday, I will be, which is the next time we meet, going through an example problem, like the test, so you get a sense for how I ask questions. I'll also go through how I grade them, so you're not figuring that out the first time that we get. And then those are the Check Your Understanding problems that are listed in Module 5 on the Check Your Understanding page, which is where I'll also be posting this video after I upload it later today. It's now 9:30. You are free to go.